Okay, so we're live, we're good. This is gonna happen. This will be good. Right. Fantastic.
All right, we are there. Oh, that's amazing. We switch up the icon on the side. So, open the app. And run meeting again. Our stream is working.
Well, it's several seconds behind. It'll be about 30.
Yeah. So,
Oh, a minute.
can I get you water? All right. So it should, yes. So you can log into the so you're like number 3 of that. You're 3. You should. Go down to the yards. Said you said no. Maybe you said yes. Oh, you may be having, you may, no, you're not running questions. Are you upgrading the new lead feedback? For you. Okay, so you're in. All right, so what you want to do, I will do yes. We use or any all right, we are. So welcome to Houston Data Visualization. We are a meetup talking about data visualization. It's a way to hack human perception so you can communicate more than you can with just tables and text or narrative language. Have some cool people from Plotly with us. Be sure and say hi to Rich, who's amongst us right back there. And then a warm welcome to Matt Sunquist.
Hi, my name is Matt. I wonder if I could make a generally sacrilegious request and ask if you have a laptop that it you plugged in. I'm already a bad public speaker, and it makes me nervous when people have lots of laptop symptoms because it's boring.
Oh, gee, Mike, you just said all this time. It's my
name is Matt, and I'm working on this project called Plotly. We do web-based graphics. One thing that would be helpful, I know what's interesting to you guys, is just like if I show of hand, people can indicate to me what they use to make the graphics now. So I just make MATLAB, Excel, other things I've been. Okay, cool. So we have the way that we approach things is, I'm assuming lots of people in here use GitHub. We love and use GitHub at Plotly. We have essentially tried to mentally model it off of what you do for code on GitHub. We want to be able to let you do for data and graphs on Plotly. So we have APIs for Python and MATLAB and R, and Node, and then you can stream data for Arduinos and Raspberry Pis. And then we have figure converters that turn the plots from Python and MATLAB and R into D3 graphs on the web that you can edit with other people. So that's kind of like the general overview. Let's check out some graphs. So here I'm running an IPython notebook, which if you don't use IPython, you should check it out. It's really awesome. It lets you do kind of like browser-based. It's really let's say you can do like markdown or maybe like live plots here. So it's pretty cool. And then like when you run cells, it just converts it into text for you.
To increase the zoom just a little bit? Better.
So this is just a notebook here. I'm importing everything that I'm going to use in this notebook. And then bringing Plotly. Plotly is just on it. I'm using Pandas here, which for those of you who don't use Python is essentially like this library by this guy Wes to try and add like our like attributes of manipulating data to Python. So
our data frames for Python.
So here, like we're reading the CSV, we check out the data, and so this is a data set of countries and the number of users on Facebook from each of those countries. So then we can just plot from this data frame. So we call the data frame, we name it, we declare the type as a box plot, we for the box point show all, we add jitter, and then we set up a dictionary, and then call the figure, and the figure just embeds into our Python notebook, and we use D3 to render it. So then when you get like cover text and all of this stuff on it, and the plot can be just like it's at a URL. So I'll show one more, and then we can get into URLness. So this is a matplotlib plot here, just rendered as a PNG. And then the fun thing is all of this just like for converting the matplotlib figure, and we have this exact same plotting routine from ggplot2 for R and for MATLAB figure objects, where you call iplot and it brings the plot right in here, and then like we can zoom, it automatically does hover text for me. We can like specify like where we want access to zoom to. And then because it's here in iframe, we can also just click back out of it. And so the iframe then lets me just go to the URL for it, and I can see all of the data for the plot. I can see the code to reproduce it. So even though I made this plot originally as a matplotlib plot from Python, I can convert that plot into R or into MATLAB or into other languages, and I can upload other files if I want to be like an accompaniment to that. So in this case, like I was going to load that Python notebook and share that, and then maybe like the static version of it. So I can just export PNG files from the URL, SVG files. I can do the same thing to get like the R script for it, or like I can just use like a one-liner for a .embed, and that just gives me the whole plot. And so that's the routine from Python for kind of like doing this. I will also show MATLAB R. So this is doing this in R. So this is R Studio. It's like a GUI for R. And here I have already done this once, so you'll see what's going to happen here. But so I call ggplot, I make the plot, and this is like the ggplot version of it. But then I call plotly through the URL, and it sends the plot up here. And this is the same figure, but drawn with D3, and it's web-based. And I can toggle traces and turn them on and off and filter them. And you can also do this cool thing.
Can you back up and do that a little harder?
Yeah.
We'll do it.
Yeah, you just press the button. Yep. Yeah, and so that's just the default for every plot. We also have started working on sliders. So IPython has these really cool widget features that you can use, and we'll add this in probably like into our own life. But you can do, so you can kind of like add this type of, so like here we have like a 3D plot, and we can like zoom and toggle and move in and out on it. But then the fun thing is if you throw a widget in on top of it, you can pre-zoom. So
What do you mean by throw a widget on top of it?
So right here, I can move this slider, and it lets me change the frequency for the waves. So you can also do things like this same thing. So like here is the same type of experience where we can change the bin size for something. So here we've loaded like onto this here, we've loaded a data set that shows complaints to, I think this is the 311 data set in New York City. And so you can like search for different things. Like noise, there's any, or yeah, so you can just see like the different complaint types, and then like change your bin size on them and stuff like this. So these are the types of widgets that we're still very early on in, but it's like what we want to add to the native library soon enough as well. Because right now you can only do this from inside Python. And then let's do MATLAB version. So same thing, run a sign in, set up a MATLAB figure, call plotly. So it still renders the local MATLAB figure for me, but then it sends it up to plotly, and we get the 3D version of it here, and you can like move it around, play with all of this, and then the cool thing is, especially if you end up working between a lot of languages, is it's interoperable between languages. So I can make a plot with Python, someone else can draw data onto that same plot with R, or just by uploading data from Excel or something like that, because all of the data always just lives with it, and then we can add data from here or plot directly from here. So let's just like do a base example. So here we just have like, an X and a Y for a date, and then gold price. Can do like stats and fits and functions and that kind of stuff. And if you want to like customize your text or do group bys or error bars, you can do that. We can also just do like a scatter. And then plot as a scatter. And so now we have a scatter here. And we can like save and apply themes. Originally, this was almost a feature that we called Instagram because of our general affinity for Instagram, but I lost that discussion. So we can save and reapply themes to future data sets if we want to, and then like throw bits on top of it. So here, like I'll add like a linear fit, it draws the fit. I can add in the R squared, and then I just have like a footnote here. And annotation for it. And then it's all just collaborative. So now Google Docs. So public versus private, and then I can just add collaborators from here, and they'll be able to come in and check out the plot with me, or like if they want to see this in my profile, every plot that you make automatically gets added to your profile. So that's that plot that we just made over here. The GG plot one we just made.
Is this a Plotly Facebook or is it open up?
I'm not quite sure I understand.
Yeah, so he's asking about the stream. Is the stream on?
Yeah. So it's just like you can see, it's just at plot.ly/MattSunquist. So if you go there, you'll see the same thing. All of this, everything is just web-based. So we don't it's not software. So there's no download or installation. So everything we do is just like, it's free for unlimited public plotting. So it's all web-based. There's no downloads or software installation. It runs on like different browsers and OSs. You can just so every plot that I've ever made just goes into my profile here. And so I can see my plots, or if I want to, I can go to the feed and see what types of other plots that people are making and check out their work and see, I want to see what this guy does. So he writes for the club. And so I can see his plots and kind of what he's doing. And then the fun thing is because it's all still keeps the same data objects together, you can always get the interactive version, and then you can always get the data and the code for this, and then just fork your own version as one would on GitHub. Just then I just take my own version and I can do what I want from there. Yeah, sure. So this is the JSON object here. So everything.
Hey, you need to make that bigger.
Everything that we do is JSON rendered for graphing library. So if you have used JSON, you may have grown to love it as we have. It's a really great way to represent things. So we use it because it lets us do things in an interoperable way, because otherwise you wouldn't be able to translate things back and forth between languages. But it's kind of what lets you to go up and down between languages. So we have the X and the Y, and all of the data attributes of any given plot are just a nested part of that figure. So this shows like is a pretty verbose representation of it, but you can get like we're working on more minimalist versions of it, but like the cool and fun thing about it then is just like all of the data always just lays inside of here. So that means it's kind of like it's reproducible, and this has been like a big thing for us that we're excited about, is because all of us come from backgrounds in sort of like research and science and stuff like that, and it can be extremely frustrating if you see a graph and you're like, wow, that's a really dope graph, I wish I could get the data underneath it, and then because it's a PNG you can't, and you never will. And so our thought was always kind of like, well, if you put them all in the same place, then you never have to worry about that. And so like I worked at Facebook before this, and this was a huge problem for a lot of teams that I worked with, because I would do this thing where you like pull some data, make some graphs, and then like put it in an email and send it out. And someone's like, oh, can you like move this line, change this color? And you're like, sure, let me rerun everything. It'll only take 2 hours. But like a nice thing then is in this way, and then like also, I don't know if you guys do this, but I have this really bad habit of like never doing a good job of like organizing the attributes that I've made with a graph. So I have like the code, and then I have like the plots, then I have 3 or 4 different data sets, and I'm like, oh no, which one did I actually use? Blah, blah, blah. And so that's kind of like a big reason why we've tried to make it so all of it just is like the final result is always just like the entire object of the graph. So you never have to like worry about all of that kind of stuff yourself. Then one other fun thing, which I believe one of our later talks will delve into, is you can do streaming. So this is Plotly's first ever streaming graph. So you can see here, we're looking at the feed right here of the humidity and pressure and temperature streamed from Arduino, but from Raspberry Pi and asking a couple APIs. And then this is this guy's house in SoCal, and he has like a fan that kicks on at some point, and this is how he controls his thermostat. And then we also have a WebSocket API. So you can push data live, and because you can do that kind of like posting routine, which is what we just looked at, where you can kind of like run a cron job, an update to write new data onto graphs every such and such amount of time. Or if you have fast enough data, or you want to run like a loop on something, you can just run a Walsh loop. So that's what's going on here. This was written originally inside of a Python notebook, and it's just a loop that keeps running. Yes.
You guys have like an exposure to that, let's say something happened in that, and you really use it potentially certain
Yeah. Yeah, and there's kind of a couple ways you could go about that. I guess it sort of depends. So for example, let's say that like this is a graph and we're particularly concerned with like events that occurred right here. And that's like where you want people to start. You can just save that zoom. And then when you share it, that's where it zooms to. And so if someone comes in, or you can like put annotations on here as well. And then when someone comes in, it's just zoomed to that spot.
Is there any
That what?
something similar to something that happened?
So can you use a field in the data to change configuration to the plot?
We don't have anything like that right now, no. And I know like people have done stuff like that, but we don't, because like right now, so like our next big project around this streaming stuff that we're working on is having like a data API, because right now streaming essentially just streams straight to a graph. And so, but that's not what you always want, because like maybe you want like a historical instance, or like you have a whole bunch of data and you only want to graph parts of it, or you want to like transform part of it. So that's like the next project, is having a data logging API that'll have kind of like a little more capacity to, some more bells and whistles. This has worked pretty well for most use cases, but like that kind of stuff is something that we're excited about. Yeah, for sure. Yeah, yeah. But it's cool, and it lets you do a lot of cool things. Like you can have like triggers and alarms and that kind of stuff for monitoring. Yeah, for sure. Yeah.
I don't think it'll take it together between features. I don't like the Zoom and Slack and some data points. You're going to view different from different features. More from different perspectives.
Yeah. Yeah, so we have like, so this is also, if you are interested, the in IPython notebooks, you can actually run IPython, or you can now run notebooks that run R. So there's a number of, like the IPython kernel now supports R, so this is just like an R notebook that has ggplot2 running in it. So the way that that's most easily done now is, so this is like this is using facet grid from ggplot2, a delightful geom. So for here, like this just automatically has a number of shared axes. So we can have, just because those are shared axes, if I drill down into one of these, any shared graph that goes with it will similarly zoom in with it. And so it just redraws all of those. And so you can do that, and you can also like put things in like different subplots if you want to as well, and use like varied graph. These are like scatters, but if you want to, you could put like, you know, the same data. Yes.
So I know it's not exactly what you want to talk about, but something you said was intriguing, that you can now run R from within IPython.
Oh, I want to talk about that. Sure.
And you don't need R Studio or other interfaces, you just need R something on your system.
Yeah, so there's a couple ways of going after that. Really three is how that I'm aware of. And I'm not like I'm no R expert. So these are just the ways that I use it, and it's the way our team uses it, because a lot of like our backend is Python and Django. And so like a lot of us are more familiar with Python. So one route is Domino, which, and this is like this notebook that I have here is just like, so Domino is this cool startup that we've started working with, and they just let you run notebooks here. And all you do is you literally just like pick a notebook and you say R, and then it'll run an R session for me. And so I can just like,
And it's running on their server,
Yep.
sort of like Google Docs is running on there.
yeah, so you run, and they spin up an instance for you when you do that. And so you can run jobs there. The other way of doing it is Rackspace has this new bare metal server that you can use, and you can deploy the same way where they just have 10 notebooks that you can use. And here you go in and you can change kernels to jump into other kernels. And that's part of Project Jupyter, which is the new spin-off of what IPython was. So that's the way of doing it. Or there's a true R kernel that, that one of the core IPython devs wrote. And you can just get that here on GitHub, and then you just you like run it locally. So like I have an instance here where I have a Docker instance that I run the R kernel from locally. So like I just like call it from my terminal, and then it just spins up the notebook for me, and I can like go in and run it. And that's how I usually do it, where you just like, once you have, and we have I think the Docker instance, so I just like literally call them and just like do Docker up. It calls my VM, and then this is where I have like a Docker instance that runs like the R kernel, like it runs Plotly, it installs a couple other things, and so I can just, and like that's how Plotly does our deployments too. Of like, because we have an enterprise version of Plotly, and when we do deployments, it's just like we just give you the whole instance of like Plotly that's on the web, and you just set up a VM to run it locally. So we use Docker for that same thing. and now my kernel is running. And so now I can just call it the like the R kernel from here, and then just use Python, like use the R kernel locally. Does that answer your question?
Yes.
Cool.
So is Python exactly?
It is an interactive computing environment. It's just like it essentially does, like if you've used like Mathematica, it lets you do ins and outs, like it's inputs and outputs. So like you just like literally instead of like coding out of a console, can code in Python like this. No. So it has an R distribution for it. It has a Julia one, and then a bunch of other forks of it too. Like there's Mathematica notebook, there's Pascal, there's a bunch of other ones. So we work pretty closely with them, and it's worked well because like they use kind of like a similar approach where it's like just based on and stuff like that. Because like so for our APIs we wrote, and we learned a lot from watching them because like Fernando who wrote it, like from the beginning when he started out, was like wanted it to be a language agnostic approach, and that was kind of our decision too. It's like we were just like let's do everything REST based and use JSON because then anyone can fork it and rewrite. So we have like people who've written other wrappers for other languages, and the same thing has happened with IPython, where people have written wrappers for Ruby and a bunch of other languages. Let me get this. Yeah.
So, enterprise, you say that you guys have your own Docker instances for like distributed so that you can enterprises?
Yeah.
I'm just curious how that works.
Yeah. So we do, and like Rich manages our deployment. So he's the person on that. So we do, essentially you can run it on a Linux server. And so it's kind of like what we've, so for like, you know, because we have like 130 or 40,000 people who use our public product, and that's just free and unlimited public plotting. But a lot of places have third-party restrictions, or you know, like want to be, you know, and like just like need to be able to use it locally. So that's kind of like what we've done with like Google and SpaceX and a lot of the other companies that we've done deployments with, where they just run it locally.
Yeah, it's security for the right? Yeah, it is security.
For sure. Yeah.
So in that case, you run a server, you run a VM on your server, that houses cloud, and then you can do your authentication. And
Yeah, we support like LDAP, so you can just like everything just runs entirely locally.
Sure.
So we do like, you know, we'll do, and then like once every month or two, we have like a new version with all any new features we push, and people just, you know, just like run the update for it.
yeah, we do a lot of customization too, so it's like just kind of shell and those corporations do that process. Run it on and then come back with 3 customizations that they want. And we'll ship the version, including version 1 after one. So that's the same. Typical scale. None of our corporate customers use Dropbox.
And a lot of like smaller businesses are kind of satisfied with it because we use like HTTPS and, you know, do like, we use Amazon for hosting and stuff. So this satisfies a decent number of people, but for anyone who has like, you know, third-party restrictions, it's just like a non-starter. And originally we thought like Docker was a huge win for us because we originally were like, yeah, we'll just put it on servers and mail it to people. And then we like thought about the, you know, scalability of that. Like, oh, no, that's not going to work. And then there's this guy on our team named Jody who used to work at Sun, and he's just like, whatever Jody says, I'm just like, yeah, that sounds good. And Jody, so like Jody has like kind of been like our deployment guru, and it's like it's cool because we use our Docker instance, and so it's like what, and then like we just ship the exact same thing that we actually run. So it's cool, and it's like it's nice because, you know, a lot of times I think you end up running into this problem where you have like your hosted version, you have like, and then you have to figure out how you're going to expose features from the APIs for it. And then if you're doing like an on-premise version, that's a different version. And so you're pushing to all these different places at different times. And how do you make sure they're compatible? And so we've kind of like, Docker has been a great way being able to kind of like skirt that by having just sort of like from the beginning deciding like we're going to just like expose everything from the APIs and then just like host it centrally with Docker and deploy from there too. So that's been really nice. Yeah.
All right, you got a bunch of these notebooks, which are lovely,
for researchers, for people who are doing one-off types of things. But in order to make thousands of people be able to be comfortable with it, you've got to be able to put a wrapper on the front of it. That gives you the controls, the inputs, the other thing that you want, plus the main output. If you'd like to hook to any notebook. That technology there.
I'm not quite sure I understand you.
So I think he's talking about like the workplace. So if you have like enterprise cloud review module,
Yeah. So it's the exact same thing. So like because like the notebook.
maybe we show that really quick and see if that's what Steve's thinking of. We saw it before.
Yeah. So every graph that you make can be just like embedded in dashboards or in iframes or blog posts, and then you can just edit it all from here. So this is like our GUI, and this is where, because we have like we have even a lot of like elementary school students who use it. We have 30,000 users on our Chrome app, and we're part of the Google Chrome Education App Pack now.
Well, for instance, where's the input to that page? I'm seeing the output.
Yeah, so you press import, and you can bring in data from anywhere.
And then if you press view data,
Yeah, and then you can just press view data, and then we have a grid for the data, and it's all here. Or you can just make new grids here, and you can do copy and paste routines from here. So I can just like copy and paste from Excel or any grid view that I have, and then just like plot them here. And so this is where like the majority of our users are actually web users, of people who are, like don't want to buy software or like want to get like publication quality kind of like interactive plotting, and just like want to bring in data from wherever. So we have here, like some X and Y data. So you can just like press, this is how you plot. So you press X and Y, we can do like stats from here. So
Yeah, I'm talking about abstracting it just a little bit more, so that what you have is a web interface. Just a standard web interface with a bunch of little controls, but those things are hooked to AFE. Such that you want to take a look at what the drilling information was from 12 streams coming off of one rig. You got a well name. I want to see it today. This rig today. It goes, pulls the data, and brings it in. It's an automated process on the notebook. But you want to protect people from the notebook with the minimal input that they need.
So then would you like take the plot, take the iframe, and put it in your web app or put it in your dashboard from your existing?
yeah. So the way that's that's an important thing. That's not really what we're trying to build.
You know if anybody's doing it yet.
Yeah, because our thought has kind of been like, we're just like, we really want to focus on graphing and like let other people build the things around it and on top of it that they want to. And like we've just like, really focused on graphs, and like that's, like where everything that we put our attention into is. And then other people build things on top of it and have like, like people have done, and actually there's a couple oil companies that have done stuff like that where they've built their own like SQL editors on top of it, and you can like run queries on it, and then it'll make graphs for them. And we'll probably end up doing things closer and closer to that, but like most of our focus now has just been on the graphing layer, because other people just continually build. Like we now have a bunch of other people who come and build. It's kind of this fun thing where yeah, so all of the figure converters that we have are just on GitHub, and so that's where we have like our MATLAB and our ggplot stuff, and then we have a couple user projects up there, and then some folks, for example, like delightful hosts, make pull requests when they find things that surprise them or some of our hidden features. And like, so we just host all of our stuff, like all of that on GitHub. And a fun thing then about like exposing all of that through APIs is there are people who can kind of build on top of it. So this is the Wikipedia page about population for countries. And there's this site or this tool called Importio that does web crawling. And so we just go here and we press list of countries and dependencies. And it's like beautiful soup if you've used that for Python where they have a web parser. And so now we have the data right here, and they turned it into a spreadsheet for you. And then you can go over here and send that data right over to Plotly. So we'll go like number, and you can pick out which ones you want to do. And then they've just built a wrapper that sends right onto the data grid portion of our REST API. And so you can just pass the data over, and now all of it just is like part of a grid here. Or if you guys have ever heard of Quandle, which is this like pretty cool public repository. They have like 8 or 9 million data sets or something like that.
It's amazing for financial.
Yeah. So they have the same thing where we can just go in and they send over any data set from there into Plotly, and then we guess, and that's a small thing, so it's not an awesome example, but then, we guess we can have the plot for it there. So that's kind of been like a fun thing where just by like exposing a lot of like our functionality, our libraries, people have wrapped around either just like the REST API, and like in this case, like Quandle and Importio haven't like open sourced their stuff, but it's fun because like you can use the tools together, and there's like 4 or 5 other companies that have started doing that now, where they just kind of have like an import button that just like lets you send over data. So that's been kind of fun. Other questions? Was this the like huh? Was that
Moscow.
Oh yeah, for sure, dude.
That might be exciting.
All right.
Yes.
Wow.
What's your client thinking?
So the folks in here read stuff by Edward Tufte. So he's this really cool and fun guy who writes these books about data visualization. And he recently read one of them and thought that it would be fun to try and remake some of the charts that he talks about in a lot of his books, but of like seeing if we could make them in Plotly. So these are some that were inspired him, others come from other sources, but this one is the one that he talked about and has really seemed to have popularized. Folks in here have seen this. Who would like to? I saw you raise your hand. Do you want to explain it?
This is deploying March in Moscow. So on the left side where it's March, you see how large his force was in terms of power. You see force of it really large. So he sent a couple thousand men north, a couple thousand men on a northeasterly group kept on going. And they marched up on Moscow in the winter. And so basically, the people just started dying because of the cold. The day Moscow sort of failed and turned back. That's the black line. And so you can see the forces keep on dwindling as they come back. And so, like here, you can see his northeastern pass group rejoined. Similarly, his northern pass group rejoined. At the end of it, basically, this tiny little black sliver was the number of men they had left compared to the giant amount they're left with. So this is the same march where Napoleon tried to unsuccessfully commit suicide because his timetable had been watered down from all the ice and the snow as he was marching on Moscow. So this is why you never invade Russia in winter.
And in fact, the temperature graph of the return trip was down below the road.
Yeah, so we see temperature and date along the bottom, and then the distance is scaled as well for the trip. So here's like a basic remake of it that shows just kind of like a slightly hacked version of it. But a fun thing to do is to kind of like go for a different approach. So this one shows all the data here. And so we can see, you know, his starting troop numbers here, the advance, the reaching. And on the bottom here, we have two x-axes. So one is the dates, and then the other one is actually the distance across. The retreat begins in Moscow. And then as you can see up here on the original, the temperature is actually only part of the return leg. So it only maps to the black line here. And so starting at the retreat is where the temperature comes in, and we have a second y-axis here that shows the retreat that goes with it. And so it shows the same data here in kind of like another fun and different approach. This is this map that this guy John Snow made. It shows info about a cholera outbreak in London. And here there was this pump that was the cause of some of these problems. But when he tested the water, he couldn't find anything wrong with it. But once he actually calculated and it showed the number of deaths that were happening in each street, which are these black bars here, he was able to show the local city council that like something was wrong with that pump. And so they like turned off the pump and took away the handle. So this remake of it in ggplot2 using our figure converter here. And so we're using like some opacity here, and you can see that as we zoom, then you can see a little more exposure to each point. And then you can do overlaid polygons with it that show a nearest neighbor. And each of these regions here shows, and the gray line of streets, each of the regions shows where someone would walk if they just walked to the nearest pump to them. And then we can like filter and turn off the streets, and then also we can turn off the deaths, and we use custom cover text here. So we can see in each region the number of deaths that were happening in each region. Then this is another pretty famous one. Florence Nightingale, the inventor of the polar chart. And this showed a number of, also another rather morbid chart. I'm realizing now I have three of those in a row.
Florence Nightingale invented the polar chart?
Mm-hmm. Yeah, so this is the first one. And she, so it has like death counts here for varied causes. So preventable diseases are the large gray ones, and then injuries, and then like other wounds. But like pie charts can be a little confusing because they don't let you do like an eyeball comparison like you can with a bar chart. So we can do it as a polar chart, and if you have the hover text with it, it shows you a little more about what's going on, so you can make a bit more of a comparison. Or we can just do it as a stack bar chart. And you know, it's like kind of like one of these classic scientific trade-offs where it's like it looks a lot better if you do this one as a line chart. But you know, the data wasn't originally gathered in that format necessarily, because if you do it as a line chart, it looks like it's continual. But if you do it by month, then it gives you kind of like a slice of it. And then the fun thing is just throw a box plot in here with it, because the same data side by side with it. Yeah.
So, next philosophy, which is, does Motley have the ability to draw a chart that you guys sort of more conceptualize? And it looks like an incredible diversity, but there's nothing to tell us about chart types. That one thing that you realize I would need.
Yeah, so we can do like 15 or so plot types ourselves, and then you can kind of like customize, and then you can blend them together. Here is an example of a chart that we support, which is this is CT scan data, and this guy just generated data and made his own library processor. or like we don't natively support maps. Yeah, he used scikit image and then generated data for the he wanted like Python pixel data so he could see density with it. We don't natively support maps yet. That's coming soon. But we can make maps by using lat long data as the orientation. Or like here's like a bubble chart overlaid on top of a scatter chart. Here is a scatter chart with lat long data with a contour map overlay on top of it. Here is where did it go? Here's like a 3D plot of Earth that we can zoom around with. So while we don't natively support these graph types, you can like people have sort of like hacked together their own approaches where they like will make like people have done like network graphs or all kinds of graphs that we don't necessarily support. Those would be pretty tricky to do doing, but from the APIs people can, because you can kind of like you generate the underlying data to orient the axes, you can kind of drop any kind of graph on top of that.
Something your API says was.
I mean, you could generate the data too. Again, like that would be one where you would probably like you generate data. Like that's what I did with platform. But that's actually I wrote GG1 too. Actually, so
Where's home for you?
San Francisco. I'm about to fly down. This is the Hans Rosling data set, if you guys have seen this. So we have GNP across the bottom, life expectancy across the top or across the y-axis, and these are both log axes. And each of the dots represents a country, and they are sized for population and colored for continent. And then the hover text shows us all of that data. And then it's kind of fun because we can toggle these on and off if we want to. And then if you want to zoom, if you detect opacity, we can go in and you can then just see the individual. Yeah. So this one was one we made from MySQL database, which is a fun thing. Anscombe's Quartet, if folks have seen this one. This guy Anscombe made this in the 70s. It has like identical.
Is this highly charged associative table? So if I remember right, the descriptive statistics for these four stats are like identical, right?
Yeah.
So you would say, they must be equivalent, right?
Yeah. So all of the like XY means and variance are all the exact same, but then once you plot them, you see that they're all quite different, incredibly different, and like so we can like turn them on and off to see it like they're actually
Vertical line and outline.
Yeah. So that's kind of like another fun one. His point being like it's important to make graphs. Anscombe's Quartet. This is a chart by this guy William Playfair, who Tumpty talks a ton about and has a bunch of his charts. He invented like the line chart and line, bar, pie, and circle. So this is like one of his charts, and then so it shows like line of imports here, and then line of exports from England to Denmark and Norway. And it's kind of an interesting one too, because he's like says, the bottom line is divided into years, which, and it's always sort of like a fact. It has like years across the bottom, and then underneath it, it says like the x-axis plate says years. But it's like data from these years to these years. Yep, got it. But I guess if you're inventing a line chart, you would probably need to orient people to the idea of the x-axis. So we can do like the same thing here and have like the data shown in the same way. And now this one with the log axis there.
Now you have just laid on the text, an XY points on The labels, exports. Line it.
Yeah, there's just annotations. So there's I can add annotation programmatically, or just like. So in that case, we can add an annotation here. The background is difficult, but so we can like let's. Arrow style, put this here, and then the and then it just reads the HTML tags for it. So you can put in notes there, and you can add like live links or lit tag for formulas or something like that. And then the annotation that you saw over there was one that's like hidden for it, and then angled the text so that it would look like it was in line with the actual one itself. But yeah.
And that now honors the Zoom?
Huh?
Does that honor the Zoom?
You can anchor it to either the page or to the data. So it depends on how you want it to be.
Cool.
So absolutely wrong.
Yeah. But yeah, so I should probably run because I have a flight tonight.
You guys have any further questions? Everybody else can do chips. Really not going to follow them, like I know did make it. So really like that.
Yeah, so that's pretty cool mess. Better. Will show us, alongside that, UV light sensor, maybe an air quality sensor, and so those are the three things.
Oh, okay. No, I was here just for the first one. It's not the same. Thank you.
So, I'll let you set out. Can you move the computer here so you can look at the screen and look out at us? We'll take a look at it. You don't think they're going to I mean, so on the video, you can't see the screen. You don't want to show around the edge. I don't want to show.
Yeah, yeah.
Okay, hello everyone. Feel free to get more drinks. That last sandwich. And give your attention to Steve Randy. I'll let him introduce himself. Quick, we'll be 5 minutes or so.
Okay. My name is Steve Racy. I'm a visualization business architect entrance. I'm a geophysicist and operations research analyst in the gas industry for years. What you're looking at now is Spotfire. It's a visualization product that's been 15 years. And I'm going to show you some things that we've done with it in that. You're looking at public data from the BOEM, the Bureau of Offshore Energy Management. So these are just shape files. So the projection areas for the leases in the Gulf of Mexico, where we drill oil and gas. Now, we can go over here to this other tab here. These are called DXP files, and they're really kind of like workbooks. So it comes with a map layer, so that you can just show basic geography, and then another layer that shows a particular shape file that you are having. These are the projection areas: Green Canyon, Mississippi Canyon. And as you zoom in, you can have other layers with the data visible as a function of your zoom. And what we're going to do here is that we are, I can select off and see all of the areas in the Gulf of Mexico. These are the current leases that are owned by companies that have been paid for by sealed bid. And the ones that are in green are currently producing, and therefore they will be owned as long as they're going to be producing and paying royalties to the government. And those that are in orange, yellow, they are the ones that are for exploration. So they've got a term on them, 5 years, 8 years, 10 years, depending upon the water depth. And what we're interested in, for instance, is that we are saying, I have an interest in looking at blocks. Alt drag. I have an interest in looking at these leases right here. Okay, I'm interested in the geology of them. So I want to know something about those leases that are either leased, producing, or not leased right now. So I'm going to zoom right in a little more. And we've got over here, they're colored by the expiry date, or rather the status of the lease. We're going to switch to another tab where we've zoomed in a little bit further. In fact, if I zoom out, you'll see that it's the same one, but we're now showing just the leases that we're interested in. We'll zoom in, we'll get back some of the data. Because I've got another layer right here. It gives me the block numbers. So they show up as we zoom in. I wanted to do here is that for these leases, I wanted to find out how much acreage is going to expire by what year in the quarter. So we got a little history here. And I'm saying, all right, look at the leases that are going to expire in 2019. I can highlight those. Whoop, try that again. I think I need to be on. Oh, there we go. Okay, those are the ones. Want to try another one? How about the stuff that's going to expire here? It's them. Okay, you get your graphics to work on each one. That's one of the beauties of software. You've got other things over here. For instance, these are the blocks that were sold in a particular sale. So these are sold, and you can go and find out the actual leases that were purchased, and you've got the who, for how much, whatever. Over here to this map, I'm going to come back. And I'm going to bring back all of the leases that I originally had here. Okay, bring them up. And in fact, I wanted to really know, if I'm only the ones that might have, those are the ones that are going to expire in the next 2 years. Okay, so it's too soon for me to make a deal on them, but I might need to buy them. All right, with that information, there's also some blocks over here that aren't owned by anybody. We may need to buy them or put a bid on them in the next lease sale or the next lease sale after that. You also get this list, you'll get that list of information and how many blocks we've got over here that's all tied together. And come over here. I also want to know the pipelines that are in that area. What's the pipelines? What products do we do? What pipeline is that particular area? Again, it all still works off of a selection. That's what you get. Okay. All these are public shapefiles. Okay. Arc Esri Arc info shapefiles. Just read them in as table data. Real quick, I want to show you a project I'm working on right now. Real quick. Where is it? This one. Bring that over here. Many of you have spent some time in the oil and gas business. You'll recognize what these are. Okay? These are roll-off plots. Panels of roll-off plots. All right, and what you do is, what's interesting about them is that they go by depth vertically. So 0 at the top, 14,000 feet at the bottom, whatever, however it is. You've got multiple scales. Okay? And by industry convention, the scales are on top. So this blue curve is bit weight from 0 to 30,000 pounds. The red curve is the top drive RPM from 0 to 60 revolutions per minute. And this is the block height. As you drop the drill string into the hole as you're drilling it, the block is what's at the top, so it's 90 feet off the rig floor down to 0, and then bring in some new pipe. We do it again. That's what the zigzag is for. So you're looking at daily drill operations. Yes, sir.
Are those imported directly from the
They can come in from a database. They can come in from CSV. They can come in from any sort of tabular data. Okay. Now there's some magic about how we do these sorts of things, because the message I wanted to give you here is that look at your graphic libraries. How many of them can put the x-axis vertically and give you multiple Ys horizontal. R doesn't even have it. This is the way the oil industry has been looking at data for 80 years. You know, there's a pile of money to be made by showing data this way.
No, that's actually thinking that data is odd because we imagine you waiting for all the pieces of value.
Well, there's lots of little pieces, but look at the nature of this curve. Okay, this is industry standards, and one of the beauties of doing it with Spotfire is that it allows you then, you know, to do some scatter plots on the data, and then let it light up. But just the graphics, you have one x-axis. Okay, it is an x-axis with multiple lines. But what's different is we rotate it at 90 degrees. If you know of an R package that does that, no. Because you need multiple Ys. You can do multiple Ys, yes. Vertically. You need to do it horizontally.
This is the reason you can't do it because the software is interpreted as a compute, so it's going, let's see, things can go up and down, but they go back and forth.
Because everybody thinks in terms of one X, multiple Ys, X is always horizontal and Y is always vertical.
It's just the name of it.
No, it's not. I think because you need to have that business of I got one X, but I have many curves. Okay, now I plotted X depth horizontally. I could have all kinds of packages that will give me multiple Y curves. But that's not the way the industry looks at it. It is not the same.
You just looks down here, so you're
Like I said, if you want to rotate the monitor so it looks like that, that's fine. Okay, but that's the way the industry expects it to be seen. And there are custom built packages in the industry that does that for thousands and thousands of dollars a seat.
And there's an easy implementation. We want to see it.
That's plus. And well, there are ways to do it, but there's one thing. Industry. They've been looking at it for 80 years, and they don't like computer scientists telling them, well, you have to change. It doesn't go over in this business. What they want to see is the scales at the top. Because you put them in half scale. You know, Spotfire puts the legend on the side, left or right. Well, you know, doesn't belong there. You gotta put it on the top.
How would you pick the colors for?
The colors would be for.
So it looks like there's a red, blue, yellow diverging scale.
I mean here.
And then there,
Over here. No, the color is just used to identify which curve. Okay.
which colors out to assign to which plot?
Oh, well, in this one, I haven't hooked them up right. So I've got this right over here. Okay, so I'm still on this.
What I'm getting at is it a design choice? Is there a convention?
That is a customer convention. Customer convention as to, you know, there'll be a customer convention as to which curves were most important and will be curve one, and which curves are going to be kind of a nice to know. You know, for instance, one of the things that they look at is what is the rate of penetration, how many feet per hour versus the weight on the bit. And the amount of torque you're putting on this drill string and the number of revolutions you got doing all these things that are mattering to you. The rig is costing you $100,000 a day. Rate of penetration matters. So I just wanted to point out that we look high and low for ways of making this graph, and we are still looking, because this only gets us some of the things we need. And what they also want to have is the ability, so that it's 18 inches wide and 3 feet long. To show them they're well sitting down. So, there are Albert. We've got a couple pieces of software that they will be glad to charge $3,000 a seat for, and we're trying to figure out ways of giving you more for less.
Thank you. It is multi-purpose. I think that you have software to generate a query against all databases. Maybe you have many databases, but you want to have one graphics, set of graphics. And there's a program that you use on your computer. Correct. It gives you an interface to compose all these graphics without writing a SQL query yourself.
And you're doing visual queries, is what you're doing, and you can have multiple tables. You can link the data across the tables, and as you select on one, you're selecting data on the other.
Yeah, use multiple colors in the map. I don't think that it is pushed forward.
There's a new package called Data Vis that you do something. I haven't seen it, but I read about it. So. I think you can also call it as brushing, where you like select an area you're pointing.
Yeah, it is when you're bringing in data, you're bringing it into the table. Multiple things, they can relate them. Every column with a filter that you can use, and you can filter visually on any of the columns. Go away. You can bookmark them. You can come back to them.
So we have a couple people video.
And the ability of several different graphics so that you can drill down and go to the next way of telling the story. You can do calculations on the fly. And also, one way of thinking about it is that everything is aggregation. So, you are everything you're doing. Sometimes you've got a plot by, a marker by every row in the data. But it could be a marker for every state. It could be a marker for every formation you're going through. So, however you want to group the data, you can have a marker by color, you can have a marker by size, shape. There are about 7 different dimensions you can put on one chart. And that doesn't count when you've got multiple columns you want to view on the next one. I'm going to be showing the Spotfire at least in the lightning talk every time I come.
I think it's so short.
Actually, you can now get a web version of this thing. They call it Spotfire Cloud, which I think is for use.
So we're getting set up for a set in the next lightning talk. If you have more Plotly questions or want to ask Rich, this is a good time to do that. It's a great time. Of course.
So to them, it looks fine. To me, it looks-
So we can do that. Okay, we should be able to load this link now. Yes, you can.
Okay,
That's why.
go now.
So, let's wait. Instead of doing that, let's pass it to you. You are, I bet you're sorry, a little bigger.
This is the growth screen.
We got 9.
Let's pass it to 9 and then that's
The block is off. Yeah, it is this. And then you're gonna put in another growth screen, and push it in.
So while we do this, I'd like to ask, is anyone hiring? Does your company look for analysts and people who do data visualization?
My company's
Yeah, so like, tell us quickly, have a plug.
our company is called National Energy. We do analytics for the energy industry, time series, commodities data, utilization data, some LS style stuff like we were just looking at. If it's data and it's energy related, we do fun stuff with it. We're looking for a job. Absolutely. So we're ready.
What resume will I go?
We're hiring, we're looking for front-end developers mostly. What we're building is
So should I do it by changing the resolution of the screen or do it by changing the resolution of Mathematica?
I would say, looks over here, she says the window. I don't know what you like about maybe single full screen, or you can do that.
As long as we can see it, it's fine.
No, if not, let's make it.
Upstream, downstream,
this a lot of this runs exploration.
So we are almost done right now. I'm finishing. 5 minutes.
All right, so today's a good day for live talks. This is Seth. You can tell us about yourself and
All right, so I'm Seth Chandler. I'm actually a law professor at the University of Houston, where I do a lot of work on analyzing legal data and teaching students how to use the thing most of them hate, math, in order to help solve problems. And the main tool I've used for the past about 18, 20 years is Mathematica. I've been shifting over, doing a lot of work in R, but I still really like Mathematica, and it's got some great visualization capabilities. And actually, just to talk for 1 second on a more generic issue, the most interesting part of the prior talk was sort of this convergence of a notebook interface and various ways of doing graphics. Mathematica's had a notebook interface for 15 years. It's terrific. And so it's very nice to see lots of things coming together and lots of interoperability. So that gives me great hope that if I live to be 100, I will see really great things. So I was just going to give you a quick tour of what Mathematica can do with graphics. It is extremely flexible because there's an underlying graphical language which these higher level commands like plot or contour plot can manipulate. And you can go in and use Mathematica programming to do custom manipulation. So the sort of thing you were talking about with flopping the axes and doing the labels, although it would not be a trivial matter, it could be done, I think, in Mathematica. In any event, so one of the most basic functions is plot, and to create a graph of various functions, which I've done here, this is simply the code that one needs, and it'll produce a labeled graphic. If I wanted the legends to be something fancier, I could say what each of those legends were.
So each line is a function.
Each line is a function.
Commas?
Is what?
Between commas?
Correct. There's a list here. Mathematica places different items in curly braces to denote a list, and so those are the 1, 2, 3, 4 functions that are being plotted in that diagram. So another thing Mathematica can do is plot from data, and starting with version 10, it's starting to have much more robust support for what it calls data sets, which are, I think they would candidly admit, a ripoff of R data frames. And if you understand R data frames, you will understand Mathematica data sets. And They're very similar. Anyway, we can read that in, and then we can produce a graphic based on that. Another thing we can do is make interactive graphics, and just like in R, you have Shiny and other things that permit one to make interactive graphics. I would say Mathematica is really very good at this. So here's a sort of trivial graph, and this is the basic code here, which is just plot this, but have a variable of theme, and then here are the possible values that theme can take on. And then just wrap the entire thing in a manipulate. Manipulate is sort of the generic term, just as it actually is, I think, in Shiny and some other things for Fiddlewood stuff. And so we've got a pop-up menu here, and so I can now, if I run this code, I can change the theme. If I want a scientific-looking graph, it'll do various things. Web-friendly, it'll do various things. And so it's just a very basic interface. Here's something a little more sophisticated. I've got a 3D plot. Mathematica does really nice 3D plotting. Again, I've selected, here's the basic code, and simply some of the things like alpha, which is going to drive the frequency of the sine curve, and it's going to be a variable here, permitted it to have certain ranges. So if I run this, I can now change alpha, and you'll see the graphic move in response to it. Or if I want large labels, it'll make large labels. Or if I want the mesh to be contours, it'll make the mesh to be contours. Or whatever it is that I want. The code is very simple. You simply, instead of writing a value, put a variable in, and then it's the last arguments of the manipulate command, simply specify what values that variable can take on. Or another one with contour plots, and hopefully you're getting the picture. It can also do fairly sophisticated things, such as a 3D contour plot with various levels of opacity, and I have lighting models for it, so I tried to illustrate that here. Here's something else that it can do, which is it can take data. Here it's taking data from its proprietary database. Mathematica comes with all sorts of data baked in, and the ability to query the Wolfram Alpha database, which has all sorts of data as well. You can use it, if you know a little code, to query things like the Quandl database and others, suck it all in, and produce things like bubble charts based on that. So here you can see that you're getting information on South Africa and Nigeria. So this is poverty fraction and the log of GDP per capita, sort of a Hans Rosling kind of thing again. Here's another thing where I got the temperatures in France for various cities, and I believe they are sized by population. So that's the temperature in Paris and Aix-en-Provence and Toulouse, etc. We can make histograms. I don't remember the provenance. I think I was trying to do something that looked like an R histogram or a ggplot histogram. In any event, the syntax for all of these is very similar. Or here's another thing I did. You can have custom gauges. Here I sucked in the temperature data for Houston for today, and then made a plot of it as of 7:07 this evening. And so you can see that it actually got quite warm in Houston this afternoon, and is cooling off, and it's got a little clock and a little current thermometer. For those of you who have middle school students, price of Mathematica, you get the ability to do number line plots and save yourself. Or for those of you who are economists, this is sort of the standard constrained maximization problem where you have a utility function, which is represented some bugs, and a budget constraint, which is represented by the amount you're spending depending on the price being less than some value, and it's going to produce a constraint, a contour plot showing, roughly speaking, where that function is maximized within permissible bounds. So those are some very basic things you can do in Mathematica, and I'll just show you a little more pictures, and you tell me when it's time to go home and you're bored and all that. All right, so here's one more from my domain, which is using Mathematica to do some computational linguistics along with some networking. So there's something in the law called the Convention on the International Sale of Goods, which governs certain commercial transactions that take place between different countries. And so it has various articles that are listed in it, which go from like 1 to 100 and something. And one of the things I'm pushing in is trying to see if we can find some latent structure in the Convention on the International Sale of Goods by looking, for example, for the longest subsequent common words that might exist within various articles. So that if one article were to say no sale is valid unless, and another article were to say no sale is valid unless, that's a suggestion that those two articles have something in common, and therefore you might want to look at them in conjunction. So the code that you're seeing here is relying on some abilities of Mathematica and computational linguistics. It's going to produce a dendrogram, and then we can do interesting things like producing an interactive graph showing the clusters, the communities of articles, of provisions of the Convention on the Sale, Convention on the International Sale of Goods. And so it's one of the visualization capacities that you get with Mathematica is a lot of stuff on networking with different layouts that are possible. So similar, I guess, in R, there's an iGraph package and a couple of others, and I know Python has network packs. Anyway, there are a bunch of things, and they all have somewhat similar capabilities. So let's do one more, and this was actually motivated, I think, by a talk that I attended here earlier. This one's on crime in Houston, and so there's every couple of days, the Houston Police Department sticks up on some web page everyone who's been arrested for as far as I can figure out, anything in Houston. I fix it on this embarrassing site, and so we're going to suck it in. Mathematical function called semantic import string, which was very similar, I think, to what that import IO function was doing that the Plotly boys talked about, which is that it's trying to ascribe some meaning to what's being sucked in, so that maybe it knows that this is a date, and it knows that this is a state, and that this is a city. And so once that's in there, because Mathematica has lots of data built into it, it knows Victoria, Texas. And so there's sort of a built-in relational database within what you've managed to suck in. So I basically wanted, I guess it's sort of the typical thing of seeing where is crime, where are arrest patterns highest, and produced a little, what some, I think, R calls a chloropleth, which seems a very ugly word. And it's this graph that you've seen a million times, and it has different names. Mathematica calls it a georegion value plot, which may not be very euphonious, but there it is. And so it's giving you a plot showing the levels of crime in Houston, okay? Or at least arrests. Yes. We're looking at it by zip code. Those are one or the other. One or the other. And I don't know which. It may be. I mean, if I'm just looking at these sort of wealthy areas, and so maybe the police don't arrest anybody. Yes, these are date of birth. Well, that's not it. I do not know. I don't think it's that long time period. It's just a couple of days because I want to keep something that was smallish. And let me just say, if you've got enormous volumes of data, Mathematica has issues. Okay? It is not perhaps the world's greatest language for analyzing terabyte data sets. All right, because Arbor has a memory restriction as well. I'm told they're working on it, and they're going to have, swap in, swap out functionality, blah, blah, blah. But in the meantime, just be aware of that limitation. So we can do other things once we have this data. We can look at the arrest grouping, and here I'm using some database functionality. We can look at the gender distribution and age of arrests by gender and age. And so we see 20 to be the peak for getting arrested. And I don't know, to me this shows, it looks like the male-female ratio is roughly constant, except when between 50 and 54, when it seems like it's mostly men. We can do a racial breakdown of the data, although it's a little odd because the police classify data racial in a way that's different than, for example, the census might. In any event, one can see the racial distribution, and here's the legend to it. U being unidentified, A's being Asian, W being white, B being black, over some time period. And you can, again, draw whatever conclusions you like from that, but that's what the data shows. So there's more one could show, but I wanted in my, I'm sure it only took a 5-minute talk to give you an idea of the capabilities of sort of combining traditional Mathematica stuff, which is working with math and functions, with more of that I know many of you might be interested in, which is working with messy data. And so these are some of the capabilities that you can see. Yeah.
What's the Mathematica?
For the student edition, which I think it's about $300. If you work at Exxon, it's about $2,500 for a license. So it is not open source software, and so one of the questions you have to ask yourself is whether the enhancements, a lot of the built-in functionality, etc., is worth that price for you, and that's a question. There's also now the Wolfram Programming Cloud, which is somewhat similar to what was being shown here in that it's a cloud environment, software as a service. You rent the space there for X dollars per month. There is a free tier, that's correct. You get essentially all of the same capabilities that you do, but it's an interface, and there are advantages and disadvantages to it.
I use it and I love it.
Uh-huh.
I just do my kids had one of those puzzles, right? I just created a way to solve that puzzle. I'm playing with it. I don't really do it for me.
Sorry.
Yeah. So what's the difference between Mathematica and this is language?
Okay, all right. So I will give you the straight answer to that. The straight answer to that is that the Wolfram language is essentially an augmented and rebadged Mathematica. It's a superset of Mathematica, where the emphasis and the reason that it was credible to rebadge it was there is all this built-in data in it. When it reads in Massachusetts, it knows a lot about Massachusetts, which you could then query. But it is not a radical departure from Mathematica itself. Mathematica is definitely a subset of the Wolfram language, and you'll find me using them interchangeably, although that might be a heresy. Sure. Any other questions? Ready to go home? I think they're ready. Yeah, go ahead.
Yeah, it's probably really close. What was the first thing you did? What was the example you saw a long time ago? Made you think about this tool?
Okay, so you have to realize, I first saw this in about 1993. I'm old. Okay, so I'll tell you what got me excited, which is trivial. Okay, but here it is. So. This is an approximation device. All right. So f, a function, an arbitrary function of x, an object, a pattern, is going to be programmed in the future to be equal to x cubed. Okay? And so now we've associated with the object f a formula, and now I can put in not just f of 4, an integer, I can put an f of 3, I can put an f of my name, and it just applies that same operation. So it's partly the polymorphism of it, and once you understand the pattern matching language of Mathematica, which at the time was way ahead of anything else and is still extraordinarily powerful, you can start to do very interesting things in pattern matching and the transformation of expressions. And then, of course, you learn that it's all sort of a unified syntax, so that I can now say, plot that function as x goes from -3 to 3, and there it is. And so this could have been done, if I did this 20 years ago, it would look roughly the same. It's prettier now, it's faster now, etc. But that was, I would say, what initially attracted to me, as well as the elegance of the sort of unified paradigm. That is, in many ways, Mathematica is Lisp. There's a head to the expression and various tails off it, and everything is crammed into that paradigm. The virtue of that being that the learning curve for subsequent features is low, because it's all going to be the same syntactical idea, and the disadvantage being that sometimes it's a little hard to shoehorn various forms of data structures and the like into a Lisp-like structure. And there are some performance penalties that are occasionally associated with that, and there are people at the back end of Mathematica who go through heroics to sort of work around those performance issues, so that the performance in general for most of the problems that I work on is completely fine. And the programming time is sufficiently lower than it might be in other languages, that the savings I get in programming time and flexibility and interactivity dwarf whatever penalty I pay for performance. But that's because the problems I tend to work on often don't involve terabytes of data or complexities of that nature. But it's a great environment for playing. And just, can I have one more sentence? For what it's worth, I taught a class this fall to law students in which they learned some Mathematica and some R. Okay? And for what it's worth, the students, most of them, ended up preferring R, which was an interesting thing, because they found it simpler. And what I tried to explain to them was that, yes, R is wonderful, I love it too, but a lot of the formulas that they're using in R, they can't derive easily from within R, because it doesn't have any, it can, but it's not built to do math, okay? So it can solve a differential equation numerically, perhaps, but it's not going to be able to figure out a formula for a differential equation. Or it can tell you how a mortgage amortizes, but it has no idea as to why that might be the formula for mortgage amortization. And so there are advantages to each of the pieces of software, and one of the things I really like about, you know, the 2015 world is this convergence and interactivity where you can use software for what it's best at and have them communicate with each other with considerably less difficulty than you would have 10 years ago. Yeah.
It will actually integrate. And the thing about Mathematica that blows me away is that it doesn't do arithmetic, it's doing algebra. It's doing calculus.
Right.
Symbolically.
Right.
You know, it's
So I have no idea.
Today I'm dumbfounded.
Interesting. It can't do that integral. I just came up with one. That's not a doable integral?
Well, the heck, you know, even if it can tell you that I can't do that one's
all right, that might be a useful thing to know. All right, so it's doing some calculus there, and or it can, let's come up with a differential equation.
I mean,
let's say that the
derivative of the CRC tables, it's impressive, but it's This is black magic from the first day I saw it.
All right, so I mean, this is not a hard calculus problem. I think even I might still be able to do it possibly on my better days. But so there, it'll do the calculus for, I can say desolve the first derivative of x divided by the negative second derivative of x is equal to a constant times x, and solve that for f of x, where x is takes the role of time. And what is its objection? Okay, I need to clear f because I defined f. All right, so it's come up with a formula, and if anyone cares, that's the formula for a utility function with constant relative risk aversion. So there it is. All right. Go home.
So before you go, I'd like to show you something else I did in Plotly, and I'm going to show this very fast and then stick around for questions. Please do, and I'll show my screen. This will be great. Okay, I'll come around. So I made a UV light sensor. It is this tiny red thing on the breadboard connected to this Arduino Uno. And I will connect the display so you can see too. And then I will update the join me. Hooray. And hooray, now you must screen this high resolution. So, Plotly has this really nice tutorial. They show you pictures of the assembled device. They show you the components you need, how to hook it up, which is what I was doing while Seth was speaking. Many talents, you know. You have some choices here. So with Arduino, you can use an Arduino sketch, and I think this is like a domain-specific language, and I think Arduino is like C. I could be wrong about that. Also, you can use Node.js, which is really quite nice because you can connect directly with USB cable instead of requiring some kind of internet shield, which costs extra money for your Arduino board. Yeah, so this whole project is like 40 bucks. So there's some bits of code and some instructions here. I've posted the link down in the comments. I won't dwell on this. To run, you say node uvsensor.js. So this is the script. And let me make it nice. Put it down here. This is JavaScript. All right, so I have this project folder. I have one file, uvsensor.js. I'll say node uvsensor.js. It gives me an address really quick to initializing the device. And whoa, there's data. Okay. So I've got it set up some really high frequency. So it's this Plotly. It gives me a link in this JSON object. So if I go visit the link in my browser, I see the stream. And I'm going to refresh it here, and then you'll see it too. So locally in my console, I see all of these readings coming from this UV light sensor. And then
change the sensor.
Right. And so I was trying this earlier. It works really well if you go out to direct sunlight. If I cover it, you'll see a small dip. So I think I need to do something. This output is, I think, voltage. And so if I change the scale, or perhaps calculate some other value, some light intensity value, it might be a nicer chart. But with some example code, and you can tell me if I'm putting the screen, there we go, that's better. Yeah, so with some fairly simple code, I can get sensor data on the internet. And if you visited this link, I'll go share it. You could see this chart as well. And so this is a fairly simple example. I have one sensor. You can connect multiple sensors. You can, of course, transform the data. So let's try Plotly. So quickly, I'll show this code here. It uses Johnny 5, which is this nice library that lets you pass JavaScript parameters or properties to control Arduino boards and things like them. So nice for DIY robotics. And then I've got credentials for Plotly to establish 2 streams. So I have these tokens for Plotly telling them I'm going to send them 2 streams of X and Y. So if I remember right, one of them is the ground voltage, which is that orange line at the bottom, and then the sensor voltage at the top. And it's coming in, so you can see we set the frequency, we map the pins to the data, and then we initialize these streams.
You can't get there.
Say what?
You can't get there, Mike. That's not lightning.
So the examples on the internet, you should study it yourself. Pretty cool. Well, I've got an air quality one I'll get out and show afterwards. But the thing that I think would be really great is to take this kind of capability of sending data from a sensor and do something like dynamically light a scene. So with 3JS, you can have this scene and with a light source. So you have a sensor in the real world. Maybe you could dynamically adjust the light in this virtual room based on some place in the real world. That's literally mapping light in some real place to light in some virtual place. But you could take other things you measure, I'm sure, and come up with a way to plot them. Or yeah, so I'm trying that and it's not responding. So maybe the that's a good idea. We'll see if it outputs UV.
Actually, I bet it does.
So I got the spike. Let's change the angle here. Let's get closer. Yeah, so there's definitely UV light coming out of the projector lens.
Scores for the energy, like, so if you were or the data, so if you were to run this for like 5 days, go back and historical, or is it only what's in the JSON?
So what Matt told us earlier is no, and they're working on it. However, there's an answer. So, oh, that was a big spike. So it's possible that I'm moving my hand around, and so it's possible that different regions have different intensities of UV light. I'm entirely speculating right now. The question, though, is how do you log the data? So right now, I'm writing it to the console. And so that's something that's really useful to do when you're working in JavaScript, either for something like this or like with a library like D3. And so, okay, after we get some data from this 3-volt pin, we set the values of X and Y in this data object to the output voltage and the timestamp, and then we write it to the console. I could just as easily say something like d3.csv or jQuery or your favorite tool, and write the data as a row to CSV, or write that data to a JSON object in a file that would be a text file that would live on your hard drive, or anywhere else. You could write a post and send the data to some other server besides Quality. So that is where you would do it. And just to demonstrate this, let's see. Yeah, so I comment it out and I save it. Stop it. I think I stopped it. Here we go. Control-C stops it. All right, so I've stopped it. There's the file. So node, name of the file. And somehow it's storing it in memory. Somehow my change that I just saved doesn't happen. So let's close the terminal. It is updating more slowly. So I want to solve this because it got my frequency, but it didn't get my change there. So I'll write it to JSON. Oh, no, that's right. So I have another, so I'm just writing less frequently. So let's find my console. Console.log is what I want to comment out. Right, so comment both of them out, so it is working. I should see no output. I should just see that JSON object that describes where my link is. So I will go back to the place where this project is and say, yep, it's there, and run it. All right, so you see the JSON object, the link, hit refresh, and nothing in the console. So this is a rabbit hole of wonderful ideas and projects, I think. It also can make your charts like really tangible. There we go.
I have been most amazed of how little the use of sensors have invaded the home, you know, when compared to computers, with our computers. You know, you just haven't seen the breakthroughs that you might have, that I expected 30 years ago. I mean, we had an Apple II. We could play masturbine, you know, with a microphone. You know, you're saying, yeah, red, yellow, blue, green, whatever. You know, I went into an audio card or something else like that. Good heavens.
So with smartphones and things like the Arduino board, we're much closer to this.
Yes, I think so.
You can buy the sensors online. SparkFun is a great vendor. There's a Seed Studio too. But anyway, talk to me more if you're curious about this kind of thing. Thank you so much for coming out. I know it's late. If you want to stick around and do introductions, I like to do this a whole lot. So maybe say your name, some affiliation you'll admit to, and you know, what kind of data you work with. So yeah, I'm Micah. I like to work with what I've showed you here. And I work at a pipeline company organizing Meetup. So Frank, who are you?
Frank Brock, City Use and Finance Department, working with financial data, and also geospatial estimate and city generates and usually.
Cool.
Data Runyon, we're on trade for commodity trading, a bit easier system.
What commodities? All of them. All right.
Colin McKay, working Halifax team. I'm using Alec to generate reports. Competency.
Yeah.
My name is Ian. I do a lot of work with energy data, all sorts of commodities, and recently I've been spending a lot of time with the TABC risk receipts data set.
Which is fantastic. I'll show them out. Go ahead, Evan.
Hi, John. My name is Ahmed. I work with Bang LA Architect. And my background is civil engineering, civil and environmental engineering.
I introduced myself earlier.
Hello, Steve. Go ahead.
My name is Yuma Yoga from Archas.
My name is Faisal. I'm a software developer for Archas. Mainly on the desktop.
IHS. Okay.
Yeah, welcome.
I'm very large,
I'm Mauricio. I work with environmental data and
Hi, I'm Jackie Chevalier. I work for mathematicians and now I'm a software developer. And I work I work to study science data. And I'm trying to do 3 data.
Welcome.
Still on physics for a few months. I mean, I started for long enough and try to be a data scientist. And somebody was program by back of a bus of different things. Somebody was a railway driver or that
Good. Good.
Hi, I'm Mohan. I'm a software expert. I'm working on the insurance transformation. I'm Vladimir. I'm a software developer for Sunshine.
Fantastic. And Seth gave a talk, everyone. This is Seth.
I'm Seth Chandler. I'm a law professor at the University of Houston, and I do lots of data analysis in diverse fields, from the Affordable Care Act to crime to finances.
So yeah, thanks for coming out. We'll do this again next month. If you have ideas for speakers or want to talk, tell me. We'll be here at TXRX Labs. If you came out to Rice for the visualization lab and want to do that again, let me know. We could do that again potentially, maybe in March or April. And yeah, thanks for coming.
Yes, sir.
So you're going that way?
Yes, I am.
Yeah, I live on West Lane. I'm just at 59. So any approach would be fine. No, I'm okay with him. You seem to live just around the corner. I just wanted to ask you very small.
The story and narrative is great.
Well, your job is to drill well.
Yeah, okay. Okay, Rose.
If there are other ways you don't care about.
But
yeah,
So second Monday monthly.
a month to drill well, so the producing
In March, there's the AICA event in March. Yeah. Sometimes we get drinks, sometimes we have a hiking after.
If
Yeah.
Because when they drill a well here, they get a well loss. When they drill a well here, they get another well loss. When they drill another well here, they get, and they put these wells like this and draw lines in between. Okay, plus they're used to looking at ground, okay, and cross sections and bed flows this way. They want to take this
And so here, what do we see?
all right. So that's oh, well, and that's the case, and now, you know, each one of those blocks, those are the 3 by 3 mile lease blocks. And so it's more like Monopoly. You know, how many of these things can we put together to have a viable prospect to drill? You know, and before you want to spend $3 million for a seismic survey over the area, you got to know that you're going to be able to buy the property in order to have the right to drill the well to get maybe the oil and gas you're looking for. So it's a big long chain of events that's got to light up. But yeah, all that is, you know, right now people are in the business of trying to figure out, should we hold on to the lease? Should we let it expire and buy it 3 years later? You know, when the prices might or might not be better. I can't afford to do well now. Can I hold on to the lease and drill it in 2 years? All that sort of stuff. Everything is wrong. You got people who bought land at $2,000 an acre and $50 a barrel. People aren't throwing themselves out of windows yet, but there are plenty of factors going on. I had a friend who said he got the Texas boot kick, you know, this last week. You know, 35 years in business, and he was in the wrong place.
So I need to 3D print a.
Yeah. Yeah.
He's not going to come. As I said, he was in the wrong place at the wrong time. He was in the Gulf of Mexico, and the Gulf of Mexico right now is a dead sea. There's nothing going on in there that hasn't got 300 momentum behind it right now.
But non-verbal communication.
So,
I'm not sure what this is. This might be art.
oh, is this
Nicholas Felton annual report, subject of a data story in this podcast. It's coming to Houston in March.
Oh, this will be fascinating.
Right. So tickets are like $25 the ABA event. We're hoping to have a free event afterwards, Q&A drinks. But yeah, this guy's kind of genius. He talked about he is the Sundance Theater downtown. So let's get into here. This is like his early work. Nicholas Felton. There's this interview with the Stefan Lawrence and Data Stories do, where he talks about the sensors that he uses to like do this light logging. And he says that he has a Fitbit and then another footstep tracker that he doesn't wear on his wrist, but he keeps it in his hand. And the gap between the Fitbit and the Nike band is the time he was not wearing pants. The Nike band is the pants.
together, like these two sensors that do a simple thing becomes this like one sensor that's a very interesting thing. It enhances the picture. So if you want to like work with sensors and compose data to do something interesting, you think about this kind of thing.
I have to admit that over the last couple of years, with this thing coming out there, boy, now you got the sensor data that's something great. But I've just been surprised how long it's taken for you to be able to, go to the Radio Shack and, buy your sensor that you can plug in. Like the Radio Shack. That's what I mean. Okay, so it'll be
Thanks while you're out.
Parameters that have in JavaScript luckily, I set up these two streams. You're actually going to the token is a unique value that it is associated with those. So these two here. So Micah stubs in this feed is how they know who it is. And here's the username and my name. That identifies as me. There are strings. So I may have many sensors, but I want to identify them flatly. Strings issued from this chart. So here I specify which so let me show the other sensor. I'll show the
programming, you see your immediate results, try things together, you see your source, you see your results, you see
That's interesting. $60. I got it 3-day shipping from Madison, New Jersey. 5-day, 920 on Amazon. I'm very happy with it.
all right, well, thank you.
Thanks for being on, Seth. So, makes this and unless you connect multiple things, I say header board, it's like a shield. But yeah, there's a like paragraph to that. Okay, so now we have so Matt was telling me there's one guy who works in Florida that really likes Arduino, like electronics, methodology. His work license starts at 100 now. So A0, A1, so here, there's an A0, and I'm going to find out which one to grab. So I need to here, I need to zero, we don't have Hello there. Hey. See you, Mike. Thanks for coming out. It was pretty cool. Yeah, it was cool. Very good. Anyway, you too. So, we managed to download it again. So, I could use the spec so it helps you. The idea is yes. Issue my N and issue my mini display for now. But the idea is you can do multiple sensors here with these two. So yeah, you can do multiple sensors, no problem. So these two, and we'll plot 2 lines and then 2 grounds. What I mean is, before you go, I think we like do the same thing. I work with this software already. I know about it. I don't know. A little bit. Okay. I was a protected notification. The first writing. Okay. I was my so I work on writing. Yeah. Do you know a guy named like Al? Yeah. We used to process data. So you're working with? So I work for now. This is a Python company. They use. So how do you know Alan? So Alan came here. Oh, he did. Last month and like 8 or 9 months ago. Did you have regular contact with him? Okay. I'll do it. But yeah. So you're he's an administrative consultant for the
So I'm an employee, and I do data visualization and then do support for commercial. So we build reports in the .NET app. We change views in the Car Builder app. We use Tableau. What do you do? An ETRM system now? Something different? Or so I left. Okay.
I know all of the work.
Make you a really good offer. Is it still mobile or is it something new? But what's the product you're working on now? I'm curious. Right. Where they're trying to make power grid. Okay. Fascinating. All of this. That's what implementation does, right? There's lots of fun. Have you met Chris McCaffrey? He's another guy here that works for SunGuard, does consulting, does very interesting things. He's I work for SunGuard. I sit across the road from SunGuard. Actually, one of the guys who built sorry, I don't mean to be rude. Have you all met David?
I think the whole time, what I asked you is that so problem one, probably all small internet models today.
So without this example,
you have 10 students.
I have 4. I will generate a token. 5.
You can say, behind is big, behind,
I can continue making tokens. Matt may have some arbitrary limit, but not one that I've found yet.
So you based on tokens, which ones?
I can have different plots. I can specify them all in one plot.
So one token was one token left, left out of common property.
Right, and tokens are associated with the user.
Okay, good. Thank you. Thank you, man.
Can I give you a card?
I don't know.
I will give you one. You should find me on LinkedIn or this.
Okay, thank you. Very good. Very good.
Eat it. Yeah, thank you guys for coming out. If you ever have a project that you want to show, or you make a demo, we do these lightning talks because of Meetup each month. Yes, I just want to stay with his name is Rob Ware. He's business side. Yeah, and like safety. Other stuff. Nice. So, save right angle. Or maybe right there too. What's the attitude towards servers? Like, build the attitude of project stack, and so you have them. Reports saying we want performance, we need to buy servers. Is there some organization that's like really front office driven that gets it? It's like, yes, we want fast servers. Because like we're a supply organization, and we want low cost. Everything I've seen, every implementation I've been on, so it's in the beginning.
Everybody always wants it back.
Let me say goodbye.
Where did you get his